Tonight, we explore the silent mechanics of a reality that is steadily stealing itself away, piece by piece, into a void we were never meant to inhabit. Imagine you are standing in a room where the floorboards are silently multiplying beneath your feet. You do not feel the motion and there is no sound of shifting wood, yet you notice that the door leading to your kitchen is a few inches further away than it was a second ago. You reach for a book on a shelf, but the shelf is retreating. You look at your hands, and for a terrifying moment, you wonder if they too are growing thin. You try to shout for help, but the air between you and the hallway is stretching so quickly that your voice, once a sharp cry, is pulled into a low, unrecognizable groan before it can reach anyone's ears. This is not a dream. It is the fundamental state of the place you call home. We have spent centuries asking what is outside the walls of this room, but we have failed to realize that the room is not growing into a larger house. The room is manufacturing more of itself, and in the process, it is erasing the map of everything that came before. At the high, frozen peak of a mountain in the Atacama Desert, a place where the air is so thin it feels like a personal insult to the lungs, a man stands alone. He is the guardian of a silence so profound it has a physical weight. Here, the sky is not a roof, it is an abyss. As he looks through the glass of a telescope, he is not merely looking at stars, he is acting as the last librarian of a library whose ink is slowly turning to ghosts. We must begin our journey here in the library of disappearing ink. Picture a hall of infinite length where every galaxy is a book resting on a shelf. In our everyday intuition, if a library expands, we imagine a construction crew adding new wings, pushing bricks into a vacant lot. But in this library, there is no vacant lot, there is no outside. Instead, as you walk down the aisles, the very tiles of the floor are duplicating. The distance between the A section and the Z section is increasing, not because the walls are moving, but because more distance is being injected into the gaps between the shelves. This is the first great deception of the cosmos. When we hear that the universe is expanding, our brains, shaped by millions of years of hunting in containers and sleeping in caves, immediately demand to know where the extra room is coming from. We assume the universe is a balloon being blown up in a kitchen, and we desperately want to know what the kitchen looks like. But the math of the 20th century delivered a crushing blow to this instinct. The kitchen does not exist. There is no room. There is no stage upon which the universe performs. The universe is the stage, the actors, and the audience. And there is nothing on the other side of the theatre walls, because the walls themselves are a trick of the light. As our librarian watches a distant smudge of light through his lens, he notices something unsettling. The light is not white, it is not even yellow, it is a deep, bruised crimson. This is the red shift, the first clue that the ink in our library is beginning to fade. In 1929, Edwin Hubble sat in the freezing cold of Mount Wilson, clutching a pipe and staring at these same smudges. He found that the further away a book was on the shelf, the faster it seemed to be fleeing. But here is where the story takes a darker turn, a detail that the standard explanations often overlook. This light is not just changing color, it is being robbed. As the space between us and that distant galaxy stretches, the light waves are forced to stretch with it. In the world of classical physics, energy is supposed to be a sacred constant. It can never be created or destroyed. But on the scale of the entire cosmos, this law is being violated in every single second. As a photon of light travels through expanding space, it loses energy. It reddens. That energy does not go into the surrounding air because there is no air. It does not go into heat. It simply vanishes. This is the energy piracy of the vacuum. The universe is a system that manufactures new space-time at the cost of the light that inhabits it. Every cubic meter of new space that is created between the galaxies comes with a fixed, intrinsic energy, what we call dark energy. It is as if the universe is a free lunch that is slowly charging the bill to the light of the stars, law vault. We are living in a reality that is essentially melting its own history to pay for its growth. The implication is enough to cause a physical sensation of vertigo. If the universe is expanding into itself by manufacturing more distance, it means that the space you are currently occupying is not a static void. It is a dynamic, roiling froth. Every atom in your body is a tiny island held together by electromagnetic forces that are, for now, strong enough to resist the gentle stretching of the floorboards beneath you. But that stretching is relentless. It does not happen somewhere else at the edge of the world. It is happening in the gap between your heartbeats and the space between your eyes. We often comfort ourselves with the idea that we are looking back in time when we look at the stars, seeing the universe as it was. But the library of disappearing ink is also a library that erases its own archives. Because the expansion is accelerating, there is a boundary called the cosmological event horizon. Right now, there are galaxies whose light is currently trying to reach our librarian's telescope, but they will never arrive. The floorboards between us and those books are multiplying faster than the speed of light. The light is traveling, straining every photon to reach us, but the distance is growing faster than it can move. Those galaxies are effectively falling off the edge of reality, not because they have reached a physical wall, but because the into has swallowed the path between us. We are living in a unique temporary window of history where the evidence of our origins is still visible. We can see the ink of the Big Bang in the faint microwave glow of the sky, but the expansion is a scavenger. It is thinning the soup. In 100 billion years, any observer standing on a mountain in the Atacama will look up and see a sky that is perfectly, terrifyingly black. Every other galaxy will have been carried beyond the horizon, leaving our descendants to believe they live in a lonely, static universe, unaware that they were once part of a vast, interconnected web. This brings us to the most disturbing question of all. If there is no outside and the universe is merely creating more of itself, what is the hardware of the vacuum actually made of? One of the greatest mismatches in the history of science lies in the weight of nothing. When physicists try to calculate the energy contained in a single cubic meter of empty space, the nothing that the universe is expanding into, they get a number so large it should have shattered the cosmos into a billion pieces the moment it began. Our theories are off by a factor of 10 to the 120th power, a 1 followed by 120 zeros. We are standing on a floor that our best math says should be 1,000 trillion times heavier than it is. This suggests that the into isn't a destination at all, but a phase transition. Perhaps the universe isn't expanding into space. Perhaps it is melting a more fundamental, non-spatial structure into the geometry of 3 dimensions. Like a block of ice melting into water, the expansion we see is just the transition of a deeper, unknown reality into the liquid form we call space and time. As the man on the mountain shuts his telescope and prepares for the dawn, he is aware of a profound irony. We came to the stars looking for a container, a room, a boundary that would tell us where we are. Instead, we found a self-contained geometry that has no need for a where. We are cocooned in a reality that is expanding into more of itself, creating its own stage as it goes, while simultaneously burning the very light that allows us to see it. The into is not a void of darkness waiting for us to arrive. The into is the silent, internal unfolding of a structure that doesn't need an outside to be infinite. We are the inhabitants of a library that is discarding its pages even as we try to read them. And as we look closer at the ink that remains, we find that the mystery isn't what lies beyond the walls, but how the walls manage to exist at all in a world that is fundamentally made of nothing but stretching shadows and stolen light. In the winter of 1929, the world was a significantly quieter place, yet at the summit of Mount Wilson, the silence was absolute. It was a cold that did not merely chill the skin, but seemed to freeze the very flow of time itself. Here, hunched over the massive iron skeleton of the 100-inch Hooker telescope, sat Edwin Hubble. To look at him was to see a man engaged in a peculiar kind of combat. He sat on a small, uncomfortable platform high above the observatory floor, wrapped in layers of heavy wool, his fingers numbed by the high-altitude air, clutching a pipe that had long since gone cold. He was not looking for beauty, he was looking for data. He was looking for the distance to the nebulae, those faint, spiral smudges of light that the scientific establishment of the day insisted were merely clouds of gas trapped within our own Milky Way. At the time, the consensus among the world's greatest minds, including Albert Einstein, was that we lived in a static universe. It was an eternal, unchanging stage, a grand, fixed house where the furniture of the stars had been arranged once and would remain forever. It was a comforting thought, a cosmic security blanket that suggested the universe had no beginning and consequently no inevitable end. But as Hubble adjusted the gears of his massive brass instrument, he was about to uncover a lie that would shatter the foundations of human intuition. Hubble's work was a tedious, grueling exercise in patience. He was searching for a specific type of star called a Cepheid variable, stars that pulse with a predictable rhythm, allowing astronomers to calculate their true distance from Earth. Every time he identified one of these cosmic mile markers in a distant spiral, the walls of our house pushed further back. He realized these weren't clouds of gas at all. They were island universes, entire galaxies situated millions of light years away. But it was when he compared these distances to the quality of the light they emitted that the great silence of the mountaintop began to feel like a scream. Working alongside his assistant Milton Humason, Hubble noticed a systematic, undeniable pattern in the light coming from these distant islands. When the light from these galaxies was passed through a prism, the signature dark lines of the chemical elements they contained were not where they were supposed to be. They were shunted, almost violently, toward the red end of the spectrum. This is what we now call redshift. In our everyday experience, we understand this through sound, the Doppler effect. When a siren speeds toward you, its pitch is high and compressed. As it passes and flees into the distance, the sound waves stretch out, and the pitch drops into a low, mournful groan. Hubble realized that light behaves the same way. If a galaxy were stationary, its light would arrive with its colors intact. If it were moving toward us, its light would be blue-shifted, compressed into tighter, more energetic waves. But almost every galaxy Hubble looked at was red. They were all moving away. And the further away a galaxy was, the more pronounced its redshift became. There was an insultingly tidy relationship between distance and speed. The deeper he looked into the library of the night sky, the faster the books were fleeing the shelves. This discovery, formalized as Hubble's law, was the existential bombshell that ended the era of the static universe. The realization was not merely that galaxies were moving, but that the entire cosmos was in a state of flight. Everything was running away from everything else. If you were to stand on a planet in the Andromeda Galaxy or a star system in the furthest reaches of the Boötes void, you would see the same terrifying sight, a universe that is systematically emptying itself. To accept this was to accept that our reality is not a fixed stage, but an event, a dynamic, unfolding process that is fundamentally different today than it was yesterday and will be unrecognizable tomorrow. But as you sit with this realization, the static universe begins to reveal itself as more than just a discarded theory. It was a psychological defense mechanism that Hubble had inadvertently dismantled. The unsettling implication of redshift is that the into we so desperately seek to understand is not a destination, but a theft. As we established in our library of disappearing ink, this light is not merely changing color, it is being robbed. In an expanding universe, energy is not a sacred constant. As the space between us and those distant galaxies stretches, the light waves are forced to stretch with it, and in that stretching they lose their energy. That energy does not go into the surrounding vacuum as heat, nor is it stored as potential energy. It simply vanishes from the ledger of reality. We are living in a universe that is manufacturing new space at the direct expense of the light of the stars. Every cubic meter of new space that appears between us and the horizon is paid for by the fading of a photon. The great silence Hubble experienced on Mount Wilson wasn't the peace of an eternal cosmos. It was the sound of a reality that is slowly, relentlessly pirating its own history. This brings us to the most disturbing realization of the 1929 discovery. The realization of the then. If the universe is expanding today, it means it was smaller yesterday. If you rewind the film of the cosmos far enough, you eventually reach a point where every galaxy, every star, and every atom you have ever loved was squeezed into an infinitely small, infinitely hot speck, the primeval atom. The static universe promised us an eternal past. Hubble's redshift gave us a birthday, and with it, the inevitable promise of a funeral. By discovering that the universe is fleeing, we discovered that we are living in the aftermath of a beginning we cannot fully comprehend, moving toward an isolation we cannot possibly escape. Imagine you are a librarian in our vast hall of disappearing ink. For centuries, you believed the library was infinite and eternal, its books always within reach. But Hubble is the librarian who finally looked at the floorboards and realized they were growing. He looked at the ink and realized it was fading from black to a bruised, ghostly red. He realized that the silence of the library isn't a sign of its permanence, but a sign of its departure. We are not standing in a house, we are standing in an explosion that has been slowed down by the sheer scale of the theater in which it is performing. The into isn't a room waiting to be filled. The into is the void created when the floor of reality duplicates itself so fast that the light can no longer hold the room together. Hubble's frozen night on Mount Wilson changed the very nature of what it means to exist. We can no longer pretend that the sky is a roof. It is a horizon that is actively receding. The great silence was the first clue that the universe is not a container for our lives, but a process that is steadily erasing the map of where we came from. Every time Hubble clutched his pipe and stared into the Hooker telescope, he was witnessing the cosmic ink being stretched until it became illegible. The static, eternal home we thought we inhabited was a lie, a perspectival artifact of our short lifespans and our tiny, local vantage point. The truth is much colder. Everything is fleeing. The energy is being pirated by the very vacuum that supports us, and we are left to watch the bruised red light of a universe that is, in every passing second, becoming a little more hollow than it was before. The bells of Lincoln Cathedral do not merely toll, they resonate with a weight that seems to pull at the very fabric of the damp English air. In the year 1253, a man named Robert Grosseteste lay beneath those stones, a bishop whose mind had wandered far beyond the ecclesiastical disputes of his day. He was a man of jagged edges and restless curiosity, a scientist born 7 centuries too early, who spent his nights obsessing over the behavior of light. Grosseteste was the first person in history to correctly explain why a rainbow arches across a bruised sky, identifying it as the refraction of light through water, a feat of intuition that preceded the modern era by an eternity. But his most dangerous thought did not involve rainbows. It involved the very beginning of the world. In medieval Naples, just a year after the bishop's death, Pope Innocent IV lay on his sickbed, his life flickering out after his forces were crushed in battle. Yet, in the shadows of the Vatican, the whispers grew into a terrifying legend. The Pope had not died of grief or illness, but had been murdered by a spectral assassin, the ghost of the Big Bang bishop Robert Grosseteste, returning to settle a score from the afterlife. While the Vatican feared his ghost, we should perhaps fear his dreams. 700 years before Albert Einstein or Edwin Hubble, Grosseteste sat in the flickering candlelight of a medieval scriptorium and imagined a primeval atom. He proposed that the entire universe began as a single point of pure light that expanded outward in a great spherical burst, thinning as it went until it condensed into the cold, hard matter of the stars and the earth. It was a vision of a cosmos that had a birthday, a moment of creation that wasn't a static decree, but a dynamic, unfolding event. This brings us to the most persistent and damaging ghost in our collective understanding of the cosmos, the idea of the Big Bang as an explosion. When you hear the term Big Bang, a name originally coined as a dismissive joke by a skeptic, your brain immediately reaches for a familiar container. You picture a cosmic firework. You imagine a tiny, glowing pearl sitting in the middle of a vast, pre-existing black void, suddenly erupting and hurling shrapnel into the darkness. You imagine the galaxies as the glowing debris of this blast, racing outward away from a central crater. But this image is a lie, and it is a lie that prevents you from seeing the true geometry of the ghost. To understand the universe, you must first fire the stage manager. In a traditional explosion, a bomb detonating in a room, the space the explosion occupies existed before the blast occurred. The room is the stage, and the explosion is the actor. But in the actual history of our reality, there was no room. The Big Bang was not an explosion in space, it was the expansion of space itself. There was no awaiting darkness, no vacant lot of nothing for the universe to occupy. The Big Bang was the moment the stage itself began to grow. Imagine the difference between a crowd of people running away from a fire in a building and a group of people standing perfectly still on a floor that is suddenly and rapidly stretching. In the first scenario, the people are moving through the building. In the second, the people aren't moving at all. The building is simply adding more floorboards between them. This is the distinction that Hubble's observations forced upon us. The galaxies are not like shrapnel flying through a void. They are more like raisins embedded in a loaf of rising bread. As the dough expands, the raisins move further apart, not because they are traveling through the dough, but because there is more dough being manufactured in the gaps between them. This leads us to a realization that causes a physical sensation of vertigo. The universe has no center. In our everyday lives, everything has a middle. Every forest has a heart, every city has a square, and every explosion has a point of origin. But the expansion of the universe is centerless. If you were to stand on a planet in a galaxy 10 billion light-years away and look at the sky, you would see exactly what we see here. Every distant galaxy fleeing away from you in every direction. You would feel as though you were standing at the very center of the expansion. Every observer, everywhere in the cosmos, is the apparent center of their own vanishing world. There is no original spot to return to, no sacred ground where the bang first banged. But why? How can something expand without a center? It is because the Big Bang did not happen at a location, it happened at a time. And because it happened to the entire fabric of space at once, the Big Bang happened everywhere simultaneously. This is the unsettling implication that your brain will try to reject. The Big Bang is happening in your living room right now. We tend to think of the beginning as a remote, historical event, something that occurred in a far-off place billions of years ago. But if you were to rewind the film of the universe, you wouldn't see the galaxies flying back to a single point in the distant sky. Instead, you would see the very space you are currently occupying, the air between your hands, the gap between your heart and your lungs, shrinking. You would see the entire infinite expanse of the universe being compressed until the density was so extreme that the ice of our three-dimensional geometry melted back into the primordial fire. The space you inhabit is not a passive, empty box. It is a participant. It is the same space that was once packed into that state of unimaginable heat and density. When you walk from one side of your room to the other, you are walking through the cooling embers of the creation event. The expansion hasn't moved the Big Bang away from us. It has merely thinned it out. We are still standing inside the explosion 13.8 billion years after the fuse was lit, watching the floorboards continue to multiply. The ghost of Robert Grosseteste was right about the light, even if he couldn't have imagined the math. He saw a universe that was a single, unified event, a geometry that created itself as it moved. But the reality is far stranger than a medieval bishop's dream. We are not standing in a room that is growing into a larger house. We are standing on a stage that is manufacturing more of itself in every second, a stage that has no walls and no outside. The unsettling truth is that we are looking for a where when we should be looking at the what. We want a center because a center gives us a sense of place. We want an into because an into gives us a sense of context. But the universe refuses to provide them. It tells us that we are cocooned in a self-contained geometry, a reality that is expanding into nothing but more of itself. The Big Bang isn't a destination we can fly to. It is the fundamental state of the very floor you are standing on, a ghost that haunts every cubic meter of the vacuum, reminding us that we are the inhabitants of an event that never truly stopped happening. In the 13th century, Grosseteste imagined light as the first form of matter. Today we see that light as a red-shifted ghost, a cooling signature of a beginning that is still present in the very air we breathe. We are the last librarians trying to map a building where the blueprints are being rewritten while we read them, and where the center is everywhere and therefore nowhere at all. If we return for a moment to our library of disappearing ink, we must confront a mystery that the librarians themselves have tried to bury in the basement of their math. We have spoken of the floorboards multiplying and the ink fading, but we have not yet asked what the floorboards are actually made of. In our everyday intuition, the nothing of the vacuum, the empty space between the shelves, is exactly that, nothing. It is a passive void, a mere absence of books. But as our understanding of the cosmos has deepened, we have discovered that the vacuum is not an empty stage. It is the most complex, roiling, and dangerously energetic substance in existence. It is the hardware of the universe, and it possesses a property that should, by all accounts, have prevented our story from ever beginning. Weight. The realization that nothing might actually be something began as a whisper in the equations of quantum field theory. On the smallest imaginable scales, far below the level of atoms, space is not a smooth, continuous fabric. It is a turbulent, ever-changing landscape known as quantum foam. In this subatomic realm, particles and antiparticles are constantly flickering into and out of existence in a frantic, microscopic dance, appearing for a trillionth of a second before vanishing back into the void. This is the seething bath of fluctuations that fills every cubic centimeter of the universe. It is the silent static of reality. And because these particles have energy, and energy is equivalent to mass, this means that empty space itself must have an intrinsic weight, a vacuum energy that exerts a physical pressure on the geometry of the world. To the modern physicist, this is the ghost in the machine. We can measure its effects in the laboratory, watching as this invisible pressure pushes on metal plates or shifts the energy levels of electrons. But when we try to take this local observation and project it onto the scale of the entire cosmos, the library floor begins to buckle. This is the vacuum energy catastrophe, a name that is not an exaggeration, but a literal description of the state of modern physics. Imagine for a moment that you are a theorist tasked with calculating the energy contained in a single cubic meter of nothing. You use your most precise quantum equations, the ones that have been tested 1 billion times over, and you arrive at a number. It is a density so colossal, roughly 10 to the power of 72 kilograms per cubic meter, that it defies any human attempt at comparison. If this were true, the vacuum of your living room would be so heavy, so packed with energy, that it would possess the gravitational pull of 1 billion galaxies. Under such a weight, the universe would not have expanded gently over billions of years. It would have shredded itself into 1 trillion pieces the moment the fuse was lit. Now, compare this to what we actually observe. We look out at the receding galaxies, we measure the gentle acceleration of the expansion, and we find that the vacuum does indeed have energy, but it is a tiny, almost imperceptible amount. It is roughly 10 to the power of minus 27 kilograms per cubic meter. When you compare the energy the vacuum should have to the energy it actually has, you find a discrepancy so vast it causes a physical sensation of vertigo. Our best theories are off by a factor of 10 to the power of 120, a 1 followed by 120 zeros. This is not a minor rounding error, it is the largest theoretical mismatch in the history of science. To understand the scale of this failure, consider that there are only about 10 to the power of 80 atoms in the entire observable universe. Our understanding of the very ground we stand on is wrong by a factor trillions of times larger than the number of atoms in existence. It suggests that our current map of the stuff the universe is made of is not just incomplete, it is fundamentally, catastrophically broken. We are the inhabitants of a library who have measured the weight of the floor and found that our blueprints are wrong by a margin that should have collapsed the entire building before the first book was ever shelved. The unsettling implication is that space is not the bottom layer of reality. We treat expansion as the stretching of a fabric, but if that fabric's energy is so poorly understood, perhaps the into we are seeking is not a physical destination at all. Some theorists now suggest that what we call expansion is actually a phase transition, a process where a deeper, non-spatial structure is melting into the three-dimensional geometry we call home. Like a block of ice melting into water, the universe isn't expanding into a room. It is transforming from a state of pure, entangled information into the liquid form of space and time. We are watching the ice of the vacuum thaw, and the resulting water is what we perceive as more distance between the stars. This brings us to a barrier in our journey, a literal wall in the archives of the library. When we look back toward the beginning of the expansion, we eventually hit a point where our telescopes can no longer see. About 380,000 years after the Big Bang, the universe was a glowing, opaque soup of plasma, a fog so thick that no photon could travel more than a few inches without scattering. This is the surface of last scattering, the final page in our library beyond which the ink is nothing but a solid wall of white noise. Peering through this cosmic fog to find the truth of our origins is perhaps the greatest challenge in the history of our species. We are forced to sift through the faint, red-shifted echoes of the past, trying to determine if our models of reality are actually correct, or if we are merely seeing what we want to see. But this struggle to find clarity in a sea of noise is not unique to the study of the stars. In our own time, we are surrounded by a different kind of fog, a relentless, accelerating expansion of information that often makes it impossible to know which way is north. Just as the early universe was a dense, impenetrable plasma, our modern media landscape is often a wall of competing narratives, bias, and hyperbole. When a major scientific discovery or a planetary event breaks, the redshift of political spin can stretch the truth until it becomes unrecognizable. This is why I use ground news as an indispensable tool for navigating this informational void. Ground news acts as a sort of gravitational lens for the media, gathering coverage from thousands of sources and placing them on a single page so you can see the geometry of the story for yourself. When you look at a headline on ground news, you aren't just seeing the text, you are seeing the metadata of the information. It provides a bias rating for every publication, along with factuality scores and ownership transparency, allowing you to see which parts of the story are being emphasized by the left, which are being championed by the right, and which are being ignored by both. In a world where the fog of misinformation is expanding faster than we can track it, having a tool that maps the blind spots in your own news feed is essential. You can visit ground.news/HOTU to see how this works in real time. And if you use my link, you can save 40% off unlimited access to their Vantage plan, the same one I use to ensure I'm not just reading the red-shifted version of reality. We find ourselves in a peculiar position. We are trying to understand the 10 to the power of 120 ghost that haunts the vacuum of space, while simultaneously trying to find our way through the informational fog of the 21st century. In both cases, the lesson is the same. The structure you assume to be true, whether it is the nothingness of space or the objectivity of your news feed, is often a trick of the light. The vacuum is not empty. It is heavy with an energy we cannot explain. The into is not a room. It is a transformation of a reality we are only just beginning to glimpse. We are standing on a stage that is not only growing but changing its very nature beneath our feet. And as we prepare to look deeper into the library, past the fog and toward the very curvature of the world, we must accept that the most frightening thing about the universe isn't its size, but how much of it is hidden in the nothing between the stars. In the hollow, echoing lecture halls of the University of Göttingen in 1857, a young man named Bernhard Riemann stood before a small, elite audience that included his aging and dying mentor, the legendary Carl Friedrich Gauss. Riemann was a man of agonizing shyness, a former theology student who had traded the certainty of the pulpit for the infinite variables of the chalkboard. Gauss, known as the Prince of Mathematicians, was a titan who had spent his life enforcing the rules of the universe with the cold precision of a judge. He had once remarked that Riemann possessed a gloriously fertile originality, but even Gauss could not have predicted the existential bombshell his protégé was about to drop. As Riemann began to speak, he was not merely delivering a lecture on geometry. He was dismantling the very stage upon which humanity had stood for 2,000 years. He was about to prove that the into, the external room we imagine the universe needs to expand, is a lie, born of a cognitive limitation we have mistaken for a physical law. To understand why Riemann's words were so dangerous, we must return to the Library of Disappearing Ink. For millennia, the library was governed by the laws of Euclid, the father of geometry. In Euclid's library, the aisles are perfectly straight. If you were to take two parallel lines of floor tiles and extend them forever, they would never meet, never diverge, and never falter. This was the parallel postulate, a comfortingly rigid grid that treated space as a passive, immovable container, a room that existed before the books were ever placed on the shelves. We are born into this Euclidean intuition. When you imagine the library expanding, you naturally picture a construction crew adding a new wing, pushing the walls outward into a vacant lot. You assume there is a somewhere else for the library to grow into, a larger arena that hosts the expansion. But Riemann, building on the remarkable theorem of his mentor Gauss, invited us to look closer at the floorboards themselves. Gauss had discovered a concept called intrinsic curvature. Imagine you are an ant living on the surface of a giant hollow sphere. To you, the surface is your entire world. You do not need to look up into the sky or down into the earth to know your world is curved. You can measure it from within. If you and a friend start at the equator, walking perfectly parallel toward the north, you will eventually collide at the pole. You didn't turn, you didn't deviate. The geometry of your world simply dictated that parallel lines must meet. This curvature is intrinsic. It is a property of the surface itself, not a result of the surface being inside a room. Riemann's stroke of genius was to take this remarkable theorem and extend it to 3, 4, and infinite dimensions. He explained that a surface, or a space, does not need an embedding room to exist. In the mathematics of Riemannian geometry, space is defined by something called the metric. The metric is the fundamental rule that tells you how to measure the distance between 2 points. It is the mathematical heart of the universe. Riemann proposed that if you have a metric, you have a reality, and that reality is perfectly self-contained. This is the moment the into begins to dissolve. If the universe is a self-contained geometry, it does not need a larger container to grow into. The expansion of the universe is not the galaxies flying outward into a pre-existing dark void like shrapnel from a bomb. Instead, the expansion is the metric itself stretching. The ruler we use to measure the distance between the shelves in our library is changing. The floor tiles are not moving across a floor. The floor is simply manufacturing more of itself between the tiles. The unsettling implication of Riemann's work is that our search for the outside of the universe is a category error. We ask, what is the universe expanding into? Because our brains were shaped by the African savanna to understand containers, to know that every river has a bank, every forest has an edge, and every box has a lid. But the universe is not a box. It is all that there is. Asking what lies outside of everything is like asking what is north of the North Pole. It is a noise that resembles a question because it follows the grammar of human language, but it refers to a structure that does not exist in the actual cosmos. Once you reach the North Pole, every direction you can possibly step is south. The grid of the world simply runs out. This realization brings a physical sensation of vertigo. It forces us to accept that we are cocooned in a self-contained geometry that has shape but no context, structure but no surroundings. We are looking for a where when we should be looking at the what. If space is not a passive stage, but a dynamic, stretching fabric that defines its own boundaries, then the into is not a physical destination. It is a linguistic phantom. In our library of disappearing ink, this means the walls you've been looking for don't exist. You could walk down the aisles for 1 trillion years, and you would never encounter a brick wall or a "keep out" sign. You would never reach a place where the universe stops and the outside begins. Whether the library is infinite and stretches forever, or whether it is finite but unbounded, looping back on itself like a video game screen where walking off the right edge brings you back to the left, In neither scenario is there an exterior. The space just connects to itself internally, a closed loop of logic that requires no higher dimensional room to host it. Riemann's lecture was the first step toward general relativity, the theory that would eventually show us that the sun doesn't pull on the Earth with an invisible rope, but rather warps the geometry of space so that the Earth is simply rolling along the straightest possible path through a bent landscape. But more than that, Riemann gave us the permission to stop looking for the room. He showed that the universe is not a guest in a larger house. The universe is the house, and it is currently remodeling its own floor plan. As Gauss sat in that lecture hall listening to his protégé dismantle the Euclidean dream, he must have realized that the static universe he had spent his life calculating was a perspectival artifact of our own smallness. We see the universe as a container because we are small enough to fit inside containers. But on the cosmic scale, there is no embedding. There is only the stretching metric, the stolen light, and the vanishing ink. The into is a lie we tell ourselves to feel less isolated. We want to believe there is a somewhere else because the alternative, that we are trapped in a self-contained event that is erasing its own history, is too cold to bear. But Riemann's geometry tells us the truth. The expansion is not a journey toward a destination. It is the silent, internal unfolding of a reality that doesn't need an outside to be infinite. We are standing on a stage that is creating itself as it goes, and there is nothing on the other side of the walls because, as Riemann finally proved, the walls themselves are a trick of the light. If we return once more to the quiet, dusty aisles of our library of disappearing ink, we find the librarian troubled by a new and more subtle form of vandalism. Previously, he was concerned with the floorboards multiplying and the shelves retreating into the gloom. But now, as he pulls a volume from the shelf, a book whose light has travelled from the furthest reaches of the Z section, he notices that the very gold leaf on the spine is dimming. The text on the pages isn't just moving away, it is losing its substance. It is as if the ink is being bled of its colour, not by time, but by the very act of existing within these expanding walls. He realizes with a start that the light he is holding is no longer as energetic as it was when it was first printed. It has been robbed. This brings us to the most unsettling paradox in all of cosmology, a concept we must call the energy piracy of the vacuum. For centuries, the bedrock of our physical reality has been a single, sacred law, the first law of thermodynamics. It is the promise that energy can never be created or destroyed, only transformed. It is the ledger that ensures the universe always balances its books. In the small, local world of our daily lives, the world of car engines, steam whistles, and burning logs, this law is absolute. If a battery dies, its energy has gone into heat and motion. If a fire goes out, its warmth has radiated into the room. Nothing is ever truly lost. It merely changes clothes. But as we zoom out to the scale of the entire cosmos, we find that the librarian's ledger is beginning to show a terrifying deficit. On the scale of the expanding universe, energy is not conserved. To see this piracy in action, we have to look at a single photon of light. Imagine a pulse of blue light leaving a distant galaxy billions of years ago. That photon is a packet of energy vibrating with a high, tight frequency. As it begins its long journey through the library, the space through which it travels is not a passive hallway, it is a dynamic, stretching fabric. As the metric of the universe stretches, the floorboards multiplying between us and the source, the photon is forced to stretch along with it. Its wavelength grows longer, its frequency drops. By the time it reaches our librarian's telescope, that energetic blue pulse has been pulled into a long, tired wave of bruised red. In any other context, we would ask where that missing energy went. If you stretch a rubber band, the energy is stored in the tension of the rubber. If you slow down a car, the energy is converted into the heat of the brakes. But when a photon is redshifted by the expansion of space, the energy doesn't go into heat. It doesn't go into the surrounding vacuum. It doesn't hide in a higher dimension. It simply vanishes. It exits reality. Every single photon that reaches us from the distant past is a ghost of its former self, having paid a distance tax to the vacuum that it can never reclaim. This is the central mystery of the energy pirates. The universe is a system that is systematically manufacturing new space-time at the direct cost of the light that inhabits it. For every cubic meter of new space that appears between the galaxies, the light traveling through that gap is thinned and drained. We are living in a reality that is essentially melting its own history, converting the energetic fire of the Big Bang into the cold, useless currency of empty distance. But where is this distance tax going? The answer lies in the culprit behind the expansion itself: dark energy. While the light of the stars is losing its grip on existence, the vacuum of space is doing something even more provocative. It is feeding on itself. In our standard model of physics, dark energy is not a thing that fills space like water in a tank. It is an intrinsic property of the vacuum itself. Every cubic meter of empty space contains a fixed, unchanging amount of this energy. This leads to a consequence that sounds like a mathematical crime. If you have a box of space and you double its size, you don't thin out the dark energy like you would thin out a gas. Instead, because dark energy is a property of the space itself, you now have twice as much dark energy as you had before. The universe is creating energy out of nowhere. It is a free lunch on a cosmic scale, a system where the more you expand, the more fuel you create to drive further expansion. It is an exponential loop, a runaway process where the vacuum acts as a pirate, stealing the energy from the light of the past to pay for the endless, empty growth of the future. One of the great pioneers of modern cosmology, Alan Guth, once famously remarked that the universe might be the ultimate free lunch. It is a poetic description of a reality that seems to have conjured billions of galaxies and an infinite expanse of space from a state of nearly zero net energy. But, as any inhabitant of the Library of Disappearing Ink can tell you, there is no such thing as a truly free lunch. The universe is a free lunch that eventually charges a price, and that price is the total, inevitable bankruptcy of everything that makes life possible. The unsettling implication is that the very mechanism that allowed our universe to grow into a vast, complex theatre for life is the same mechanism that will ultimately destroy it. By manufacturing more space, the universe is relentlessly increasing its total entropy, its state of disorder. As the galaxies are pushed further and further apart by the pirated energy of the vacuum, they become isolated. The library is no longer a shared space. It is becoming a collection of lonely, solitary rooms, separated by distances so vast that no light can ever bridge them again. We are moving toward a state known as the heat death, or the big freeze. In this distant future, the piracy will be complete. The stars will burn through their remaining fuel, and because the galaxies are too far apart to exchange new material, no new stars will be born. The ink of the universe will have been stretched so thin that it becomes perfectly transparent and perfectly cold. The temperature of the cosmos will approach absolute zero. The only things left will be the fading embers of dead suns and the occasional lonely evaporation of a black hole, radiating its mass back into a void that is expanding too fast for that energy to ever find a home. The librarian looks at the dimming gold on the books and realizes that he is a witness to a cosmic robbery. Every time the floor tiles duplicate, the universe is writing a check that the stars have to cash. We are currently living in the golden age of the library, a brief, narrow window of time where there is still enough light to read by and the shelves are still close enough to touch. But the pirates are patient. They do not need to attack, they simply need to wait for the geometry to do its work. The into we have been searching for is revealed to be a scavenger. The universe isn't expanding into a room of opportunity, it is expanding into a state of maximum emptiness. It is trading the complexity and warmth of the Big Bang for the cold, infinite uniformity of the vacuum. We are the inhabitants of a free lunch that is slowly charging the bill to our very atoms. As we sit in our comfortable living rooms, we feel the solidity of the walls and the warmth of the air, and we assume that the energy around us is a permanent fixture of reality. But Hubble, Riemann, and the modern masters of the vacuum have shown us a darker truth. The energy that powers your heart and the light that hits your eyes is a finite resource being bled dry by the very space it occupies. We are standing on a floor that is growing by stealing the light of the stars, moving toward a future where the library will be infinite, the shelves will be empty, and the silence of the Atacama will finally be absolute. Deep beneath the pastoral border of Switzerland and France, a machine of unprecedented violence and precision hums with the collective ambition of 1,000 minds. The Large Hadron Collider is more than a 27-kilometer ring of superconducting magnets. It is a cathedral of the invisible, a place where we attempt to recreate the conditions of the first second of existence. In this cold, subterranean dark, modern theorists are not just looking for particles, they are looking for gaps in reality itself. They are watching the collisions of protons with the focused intensity of a gambler watching a deck of cards, but they are not looking for what appears on the table, they are looking for what goes missing. They are hunting for the graviton, the hypothetical carrier of the force of gravity, and they are doing so because they suspect that gravity is a traitor to our three-dimensional world. If a collision occurs and a fraction of the resulting energy seemingly vanishes into thin air, it would be the first tangible proof that our universe has a leak and that there is a somewhere else for that energy to go. To understand why we have built the most expensive machine in history to look for missing energy, we must return to the Library of Disappearing Ink and reconsider the nature of its walls. We have spent our journey thus far assuming that the library, our four-dimensional space-time, is all that there is. We have followed Riemann's lead, accepting that our reality is a self-contained geometry that needs no external room to host its expansion. But there is a nagging problem, a cosmic disparity that suggests our library might not be a freestanding building, but rather a single, thin sheet of paper floating in a vast, dark archive we can never enter. This disparity is found in the sheer, humiliating weakness of gravity. It is a paradox you experience every time you use a small, cheap refrigerator magnet to pick up a paperclip. That tiny sliver of magnetized metal is able to overpower the gravitational pull of the entire Earth, all 6 sextillion tons of it, pulling on that same paperclip. In the mathematical ledger of the universe, gravity is a staggering 10 to the power of 43 times weaker than the electromagnetic force. If the four fundamental forces of nature were once united in the fires of the Big Bang, what happened to relegate gravity to such a lowly, enfeebled footing? The answer, proposed by brain world theory, is as elegant as it is disturbing. Gravity is not actually weak, it is merely diluted. In this framework, our familiar universe, the 3 dimensions of space and one of time, is a brane, short for membrane. We are tethered to this 4-dimensional surface like ants crawling across a sheet of plastic. The other forces, electromagnetism, the strong and weak nuclear forces, are made of open strings in the language of string theory, their ends firmly anchored to our brain. They are prisoners of our 3 dimensions. But the graviton is thought to be a closed string, a loop that has no ends to tether it to our world. It is free to wander. It leaks away from our reality into a higher dimensional hyperspace known as the bulk. This changes the entire context of our question about expansion. If the brain world theory is correct, the into we have been searching for is not a linguistic phantom or a mathematical trick. It is a physical, higher dimensional arena. Our universe is expanding into the bulk, growing like a bubble within a 5-dimensional hyperspace that we can never touch, never see, and never visit. We are ghosts in a larger house, forever confined to the wallpaper, catching only the faint, gravitational echoes of a reality that is vastly more substantial than our own. The stakes of this discovery are monumental. If the bulk exists, the expansion of our universe is the motion of our brain through this hyperspace, a process that might eventually lead us to bump into other neighboring universes floating in the same dark sea. Some cosmologists suggest that the Big Bang itself wasn't a beginning, but a collision, a moment when our brains smashed into another, igniting the fire of creation and starting the clock of expansion. In this view, the into is not empty. It is a dynamic, roiling medium that determines the very laws of our physics. But how do we prove the existence of a place we are forbidden from entering? We look for the inverse square law to fail. For centuries, we have known that gravity follows a strict rule. If you double the distance between two objects, their attraction drops to a quarter. But if gravity is leaking into a 5th dimension, that rule should break at very small scales. In a 5D bulk, gravity should follow an inverse cube law, dropping to 1/8 of its strength as the distance doubles. In 2021, researchers conducted a modern, high-tech version of the 18th century Cavendish experiment, using gold spheres no larger than a grain of sand to measure the pull of gravity over distances of a few dozen millimeters. So far, the inverse square law has held firm. But the search continues at even smaller scales. We are looking for the point where the geometry of the ghost reveals its higher dimensional secrets, the point where gravity decides to leave our world and enter the into. There is a profound existential weight to this theory. If we live on a brain, it means our entire observable reality is a shadow. The expansion we see through our telescopes is merely the stretching of the ink on our page, while the bulk remains the true, unreachable foundation of the cosmos. This idea received a shot in the arm in the late 1990s with the work of Juan Maldacena and the ADS/CFT correspondence. Maldacena showed that all the complex gravitational information of a 5-dimensional bulk can be perfectly encoded on its 4-dimensional boundary, much like the 3D image on a credit card hologram is stored on a 2D surface. It suggests that our entire universe, the stars, the galaxies, and you, might be a holographic projection of processes occurring in the bulk. The into is revealed to be a hyperspace where the missing 10 to the power of 120 energy might finally be accounted for. It is the place where the gravitons flee, carrying the strength of our universe with them. If this is true, our isolation is even more absolute than the cosmological event horizon suggests. Not only are the distant galaxies fleeing from us within the brain, but our entire brain is drifting through a medium we can never communicate with. We are looking out from a small, wet planet at a reality that is not only hiding its history, but hiding its very dimensions. As the theorists at the Large Hadron Collider sift through their gigabytes of data looking for that one missing graviton, they are looking for the exit sign of the universe. They are trying to find the point where the library ends and the bulk begins. If they succeed, the question, what is the universe expanding into, will finally have a physical answer, but it is an answer that brings with it a new kind of vertigo. It tells us that we are part of a multiverse so vast and so alien that our entire history is just a flicker on a membrane, a momentary vibration in a hyperspace that has no end. The into is not a void. It is a hyperspace we can never touch, yet it is the very thing that allows us to feel the weight of the world. It is the silent partner in our expansion, the dark archive that holds the pages we have lost, and the medium through which our reality is steadily drifting toward an unknown and higher dimensional fate. In the library of disappearing ink, there is a boundary we rarely talk about, not because it is a physical wall, but because it is a threshold of permanent, absolute silence. We have spent our journey thus far obsessing over the into, trying to find the room beyond the walls, but we have failed to realize that the walls are closing in on us from the inside. We are the victims of a geometric threshold known as the cosmological event horizon, a boundary that marks the ultimate limit of our causal reality. This horizon is the point where the expansion of the universe finally outruns the reach of our understanding, acting as a scavenger that is steadily erasing the map of everything that came before us. Right now, this horizon sits roughly 16 billion light-years away. It is not a physical barrier you could hit with a rocket ship, but a mathematical line in the sand drawn by the speed of light and the accelerating expansion of the vacuum. Because the expansion is speeding up, there are galaxies currently sitting within our view whose light is straining to reach us, but will never succeed. The space between us and them is manufacturing more distance faster than a photon can travel across it. These galaxies are effectively falling off the edge of the world, not because they have reached a cliff, but because the path between us has been swallowed by the very geometry of the universe. Imagine you are standing on a pier watching a ship sail toward the horizon. In our everyday experience, you assume that if you had a powerful enough telescope, you could watch that ship forever. But in the expanding cosmos, the pier is stretching. The ocean is expanding. At a certain distance, the water between you and the ship is growing faster than the ship can move toward you. The ship is still there, the sailors are still on deck, and the engines are still humming, but the light reflecting off its hull will never bridge the gap to your eyes. The ship has crossed the event horizon. It has become causally disconnected from your reality. It might as well be in another universe entirely, a ghost haunting a space you can no longer inhabit. This is happening right now in real time as you sit watching this. Every second, a new patch of the universe slides over this threshold and joins the silent majority of the cosmos that is permanently severed from us. We are losing the universe not by motion or destruction, but by the cold, relentless logic of geometry. The expansion is taking it from us smoothly and quietly, and there is nothing we can ever do to stop the theft. This brings us to a realization that carries a staggering, unsettling weight. You and I are living in the most privileged era in the history of the cosmos. We exist in a unique window of time, a brief, golden hour where the evidence of our origins is still written across the sky in letters of light. We are the only generation of observers who can look out and see the full story of the library. We can still see the cosmic microwave background, that ancient afterglow of the Big Bang that provides the blueprint of everything we know. We can still see 2 trillion galaxies receding from us, providing the undeniable proof that our reality has a history, a beginning, and a trajectory. But the expansion is a scavenger of information. It is thinning the soup of the cosmos. In 100 billion years, a span of time that is but a blink in the true life of the universe, this window will have slammed shut. Every galaxy outside of our own local neighborhood will have crossed the cosmological event horizon. They will have been carried away so fast that their light will never reach our corner of the library again. They will effectively vanish from the observable universe, leaving our descendants in a shrinking sphere of total isolation. By then, the Milky Way will no longer be the elegant spiral you see in telescopes today. It will have merged with Andromeda and our smaller neighboring galaxies to form one gargantuan, aging elliptical galaxy, a single, lonely island of stars sitting in the middle of a perfect, terrifying blackness. Future astronomers sitting on a planet in this merged galaxy will look up and see nothing. No other galaxies will be visible to their instruments. No distant clusters will provide a sense of scale. The sky will be a void, a static graveyard where the only light comes from the dying stars of their own local cluster. The cosmic microwave background, our ultimate archive of the early universe, will have been stretched so thin and redshifted so far that it will be entirely undetectable. The evidence that there was ever a Big Bang, that the universe was ever hot, dense, or small, will have been erased by the stretching of the metric. The ink of our origins will have been diluted until the pages are perfectly, hauntingly blank. These future observers will look at their solitary galaxy and conclude, with the same scientific rigor we use today, that the universe is static, eternal, and empty. They will believe they live in a single, unchanging island of matter surrounded by an infinite, hollow void. They will have no way of knowing that they were once part of a vast, interconnected web of trillions of galaxies. They will be completely, fundamentally wrong about the nature of reality, and they will have no way of ever accessing the truth. The expansion will have murdered their history. Imagine the loneliness of that future science. Imagine a civilization that spends its entire existence trying to measure the expansion of space, only to find that space appears to be perfectly still. They will develop theories of a static universe that will be perfectly consistent with every observation they can make. They will mock the idea of a Big Bang as a fairy tale, a mathematical ghost with no physical evidence to support it. They will be trapped in a lie manufactured by the very geometry of the vacuum. We are the last librarians who can still read the full text of the cosmos. We are the only ones who can still see the redshift and understand that the library is fleeing. Our era is one of a kind, a fleeting moment where the universe has expanded enough to reveal its secrets, but not so much that it has hidden them forever. If you were going to study the universe, this is the moment to do it. Not later, and certainly not much earlier, when the fog of the early plasma was too thick to see through. Right now is the window, and the window is closing. This is the true end of history. It is not a moment when time stops, but a moment when the connection between the past and the future is severed by the stretching of space. The into we have been searching for is revealed to be a scavenger that doesn't just eat space, but eats the memory of space. The universe isn't just growing into more of itself. It is growing into a state of maximum amnesia. As you look up at the stars tonight, remember that you are witnessing a disappearing act. The light you see is a stolen treasure, a fading signal from a reality that is steadily being erased. The galaxies you see in our telescopes are crossing the horizon one by one, slipping past the edge of the world and into the silence of the into. We are standing on a small, wet planet, watching the blueprints of reality being rewritten in real time, while the stars we use to navigate are being carried away into a void that will eventually leave us in the dark. The into is not a room waiting for us to arrive. The into is the silent, internal unfolding of a structure that is discarding its pages even as we try to read them. We are the inhabitants of a library that is burning its own archives to pay for its expansion, and in 100 billion years, the fire will have consumed everything but the room we are standing in. In the library of disappearing ink, our librarian has reached a point of exhaustion. For chapters, he has paced the aisles, measuring the multiplying floorboards and watching the stars on the spines of his books redden and fade. He has looked for a room beyond the walls, a higher dimensional bulk that might contain his library or a center from which the expansion began. But now, as he reaches for a volume in the deepest corner of the archives, something truly terrifying happens. His hand passes right through the shelf. The wood does not splinter, it simply isn't there. He looks down at the floorboards he has spent his life measuring, and they begin to flicker like a television screen losing its signal. He realizes with a coldness that surpasses the Chilean night that he has been asking the wrong question all along. He has been asking what the library is expanding into, assuming the library is real. But as the ink blurs into a digital static, the final deconstruction begins. The library is not a building. Space is not the bottom layer of reality. To understand this ultimate betrayal of our senses, we must leave the Chilean mountains and find ourselves in a quiet office at Harvard University in 1997. There, a young Argentine physicist named Juan Maldacena published a paper that would quietly dismantle the foundations of theoretical physics. Maldacena is a man of legendary reserve, but the idea he proposed, the ADS/CFT correspondence, was an existential bombshell. He found a mathematical relationship between two universes that appeared to have nothing in common. One was a 5-dimensional universe filled with gravity, black holes, and stretching space, an anti-de Sitter space. The other was a 4-dimensional universe with no gravity at all, a flat world of quantum particles dancing on the boundary of the first. Maldacena proved that these two worlds were actually the same. Anything happening in the vast, gravitational volume of the interior could be perfectly described by the flat quantum information on the surface. This is the holographic principle. Just as the 3-dimensional image on a credit card hologram is actually encoded on a 2-dimensional sliver of plastic, our entire 3-dimensional universe, the galaxies, the planets, and the very air between your hands, is a projection. Space in this framework is not a fundamental entity. It is a high-level pattern, a coarse-grained projection of something far more basic. But if space is the hologram, what is the ink on the plastic? What are the basic ingredients that project the illusion of volume? The answer, which has emerged with startling clarity over the last 2 decades, is quantum entanglement. Entanglement is the most quantum thing about our reality. It is the correlation where two particles are so tightly linked that they act as a single state, regardless of the distance between them. For nearly a century, we treated entanglement as a laboratory curiosity, but physicists like Mark van Ramsdonk have recently proposed that entanglement is the glue that weaves the fabric of space together. Imagine 2 regions of the library. They feel close to each other not because they are physically adjacent, but because the quantum degrees of freedom in those regions are highly entangled. Space is simply the geometric expression of how much information is being shared. To illustrate this, Van Ramsdonk proposed a disturbing thought experiment. If you were to slowly disentangle the 2 halves of a universe, the geometry between them would begin to pinch and stretch. As the quantum correlations fade, the space literally falls apart until the 2 halves are completely disconnected. There is no distance between them anymore because the glue that created the concept of distance has been dissolved. This leads us to the most unsettling implication of our entire journey, the realization that forces the into to finally vanish. If space is an emergent property of entanglement, like temperature is an emergent property of moving molecules, then the expansion of the universe is not the growth of a container. It is a change in the entanglement structure of the cosmic web. We have spent centuries picturing the universe as a balloon in a kitchen, but the truth is, closer to a block of ice melting into water. The expansion we see is a phase transition. We aren't expanding into a room, we are witnessing the melting of a more fundamental, non-spatial reality into the liquid form we perceive as three-dimensional geometry. Expansion, in this light, is just the disentangling of the universe. As the underlying quantum correlations loosen, the metric stretches, and we perceive this as more space appearing between the galaxies. We ask what the universe is expanding into, but that question is a category error. It is like asking what color the number 7 is. The number 7 doesn't have a color because color is a property of light, not mathematics. Similarly, into is a word that requires space to exist outside of space. But if space itself is just a high-level description of quantum information, there is no outside because there is no fundamental geometry for an outside to occupy. The vertigo of this realization is absolute. It means that the expansion Hubble saw in 1929 was not the flight of galaxies through an arena, but the slow rearrangement of the cosmic code. The 10 to the power of 120 mismatch in the vacuum's weight is not a failure of our math, but a clue that we are trying to weigh a shadow. We are like the future astronomers who will live in a single, lonely galaxy, convinced they understand the world, while the most important evidence has been redshifted into a digital void. The into is a linguistic phantom born of a brain that evolved to understand containers, boxes, caves, and rooms. We demand a kitchen for our balloon because we cannot conceive of a reality that isn't sitting inside something else. But Juan Maldacena and the Masters of Entanglement have shown us that the kitchen is a trick of the light. The universe is not a guest in a larger house. The universe is a self-contained holographic projection that manufactures its own stage as it disentangles. Our librarian stands in the flickering aisles and finally lets go of his ruler. He realizes that the into he was so afraid of is just the silence of the information that hasn't yet been projected into the form of a floorboard. The universe is expanding unto itself, creating more of a reality that is fundamentally made of nothing but stretching shadows and the vanishing ink of quantum correlations. The expansion is the process of the universe becoming a different kind of thing, a rearrangement of the bottom layer of reality that we, as biological observers, can only interpret as a growth into a void. As we prepare to return to the salt flats for our final look at the sky, we must accept that the most frightening thing about the cosmos isn't its size or its accelerating flight, but its transparency. We are looking for the walls of the theater, but the theater is a hologram. We are looking for the into, but the into is just the limit of the entanglement that holds our very atoms together. We are the inhabitants of a library that is not only disappearing, but was never truly there to begin with. We return, at last, to the high, frozen salt flats of the Atacama Desert, where the air remains a thin, cold insult, and the silence has only deepened since the sun slipped beneath the jagged horizon. Our librarian stands as he did before, clutching the cold metal of his telescope, but his gaze is no longer searching for a boundary or a wall. He has traversed the history of human thought, from the medieval dreams of light expanding from a primeval atom to the subterranean hunt for gravitons leaking into a 5-dimensional void. He has stood with Hubble in the freezing California night and with Riemann in the echoing lecture halls of Göttingen. Now, as the stars above him pulse with a light that is being systematically robbed of its energy by the very vacuum it traverses, he finally understands the nature of the theft. He looks down at the white, cracked earth beneath his feet and realizes that the library of disappearing ink is not a building located within a city, nor is it a guest in a larger house. The library is the only thing that exists, a self-contained architecture that is currently remodeling its own floor plan from within. This is the climax of our journey, the moment the into is finally unmasked. We have spent centuries demanding to see the outside of the universe because our brains, shaped by the practical needs of the African savanna, are hardwired for containers. We believe that every river must have a bank and every room must have a hallway, and so we assume that the expansion of the cosmos must be the colonization of a pre-existing dark arena. But the math of the 20th century has delivered a crushing, existential blow to this intuition. The into is a linguistic phantom, a noise that resembles a question but refers to a structure that does not exist in the actual cosmos. Just as there is no north of the North Pole, there is no outside of everything. The universe is not a glowing ball expanding into a black void. The universe is the stage, the actors, and the audience, and there is nothing on the other side of the theatre walls because the walls themselves are a trick of the light. As our librarian stands in the flickering aisles of the mind, he realizes that the expansion is not a journey toward a destination. It is something far more intimate and far more unsettling. The universe is expanding into more of itself. Every cubic meter of new space that appears between the galaxies is not being stolen from a vacant lot in the bulk. It is being manufactured by the metric itself. The floorboards of the library are not being pushed into a room. They are duplicating in the gaps between the shelves. This is the free lunch of the vacuum, an exponential loop where the very act of growing creates the fuel, the dark energy, needed to grow even further. The into is not a void of darkness waiting for us to arrive. It is the silent, internal unfolding of a structure that doesn't need an outside to be infinite. We must now confront the final, digital static of the deconstruction. If space is an emergent property of quantum entanglement, the glue that weaves the fabric of reality together, then the expansion we witness is merely the slow disentangling of the cosmic web. We are watching the universe become a different kind of thing, a rearrangement of the bottom layer of reality that our biological eyes can only interpret as physical growth into a void. The into is revealed to be the silence of the information that hasn't yet been projected into the form of a floorboard. Like a block of ice melting into water, the expansion is a phase transition, a shift from a state of pure, entangled code into the liquid geometry of space and time. This realization brings with it a profound sensation of vertigo. We are the inhabitants of a reality that is actively hiding its true nature behind a veil of three-dimensional intuition. We feel the solidity of the earth and the passage of time, yet we are cocooned in a self-contained geometry that is steadily erasing its own archives. The expansion is a scavenger of information, a process of maximum amnesia that is carrying the stars and the galaxies beyond the cosmological event horizon, leaving us in a shrinking sphere of total isolation. We are living in a unique temporary window of history, a golden age where the evidence of our origins is still written across the sky in letters of red-shifted light. In 100 billion years, the fire of expansion will have consumed everything but the room we are standing in. Future observers will look up from this same salt flat and see a sky that is perfectly, hauntingly black. They will conclude, with the same scientific rigor we use today, that the universe is static, eternal, and empty. They will be trapped in a lie manufactured by the very geometry of the vacuum, unaware that they were once part of a vast, interconnected web of trillions of galaxies. The into will have succeeded in its final theft. It will have murdered the memory of the cosmos. We stand on a small, wet planet orbiting an average star in an ordinary galaxy, watching the slow, patient geometric unfolding of a reality we have only just begun to glimpse. We came to the stars looking for a container, a room, or a boundary that would tell us where we are. Instead, we found a self-contained ghost, a reality that is expanding unto itself while simultaneously burning its own archives to pay for the privilege of existing. The mystery of the into was never about a destination. It was about the hardware of the vacuum and the transparency of the stage upon which we perform. We are the last librarians of a fading cosmos, mapping a building where the blueprints are being rewritten even as we read them, and where the center is everywhere, and therefore nowhere at all. The into is not a place. The into is simply more of the same incredible, terrifying, and beautiful mystery that we call home. We are cocooned in a self-contained event that has no need for an outside, drifting through a hyperspace we can never touch, while the very space between our eyes continues to stretch into the dark. You've been watching What Exactly is the Universe Expanding Into? Don't forget to like and subscribe,